Today we're going to talk about 1.2, solving for a variable or solving a literal equation. And our essential question is, what is a literal equation and how do we manipulate them? So what I want you to think about first is if you were given the area of a rectangle, and one side length, could you figure out what the other side length is? Or if you were given the area and the length, could you find the width? So go ahead and pause this video and see if you could figure out what should go in that width column for each of those dimensions. So I know that the area of a rectangle is the length times the width. I have the area and I have the length. So really what I'm saying is, what times 3 gives me 12? So the width of this first rectangle would be 4 inches. Make sure you have units there. If the area is 25 and one side length is 5, what times 5 is 25? 5 feet in this case. And lastly, if the area is 195, what times 5 is 195? And it's okay if you needed to use a calculator here. That's going to give you 39 leagues. Is going to be your side length. So think about what you just did and answer the question below. What did you do to find the width? Did you use a formula? And if so, what did you do? So pause the video, take a minute, answer that question. So what I did was we know the area of a rectangle is the length times the width. Since we had the area and the length, what I did was I asked myself, what times this length is the area, or what is the area divided by the length that I know? So if I was to write that mathematically, what I did is I said that the area divided by the length that I knew would give me the width. I created a new equation from the equation that I knew. So the equation that I knew originally, I manipulated it, I moved it around to solve for the width, because in this case, what I wanted to know was the width. So even though we just did some math mentally, what we did was we rearranged the equation of area equals length times width to meet the need that we had, which was that we were looking for the width. So we rearranged this equation, which is called a literal equation. A literal equation is when the equation is made up of multiple variables. We rearranged it, or we solved for a different variable to meet the need that we had. This is something that's really common in construction, in sciences, that you may want to manipulate things around to say, if I'm changing the area and the length, how does that affect the width? So this is something that takes place in a lot of different classes in the future, but also in a lot of different fields that you could go into for careers. Something that I want to point out about literal equations is that our final answer is not a number that solves this equation. Our final answer is a new equation with a new variable being solved for. And that's a really important thing to notice. We're not going to use set notation when we get the final answer to a problem like this, because our answer is a new equation, a formula that's going to help us better use our time in future cases. The process that we're going to use is the exact same process that we have been using to solve equations when there's only one variable. So if we're trying to get rid of something that's being added, we're going to use the subtraction property of equality. When we're trying to get rid of something that's being multiplied, we're going to use the division property of equality. So for example, if you look down here, you can see for V equals B times W times H, for the volume being the base times the width times the height, we are being given V and B and W. But what if we want to solve for H? We want this, instead of saying V equals all of this stuff, we want it to say H equals, and then all of the stuff be on the other side. So thinking about what that means that I'm going to look at this equation. I'm going to make my H in red. I want to eliminate, or to move everything that's on the same side of the equation with H. I want to move all of that to the other side. So I'm going to ask myself, what is in the way of H being isolated, or H being by itself? Well, the two things that are in the way right now are B and W. And what are B and W and H doing? They're multiplying. So in order to move them to the other side, or to manipulate the equation to get rid of them, I need to do the inverse, or the opposite of multiplying, which is division. So what I want to do here is I want to divide in order to move the stuff that I don't want, with my ultimate goal being to get h equals. I want to divide both sides. That way, this b over b divides to be 1, and this w over w divides to be 1. So all that's left is h. And then what's on the other side? The other side has a v, and it has over b times w. And yes, this is still all variables, and h equals v over bw seems like kind of a strange answer. But remember, the goal was not to get a value for h. The goal was to manipulate the equation so that we could use it to solve for h if we were given numbers to plug in for v and b and w. And that's all that we're really learning in 1.2. So now let's just look through a few more examples and see how we can manipulate those equations to solve for the variable that we want to isolate. So if you have a highlighter or a different color pen, I like to, when I'm solving literal equations, I like to go over the variable that I'm supposed to solve for, or that I'm supposed to get by itself, in a different color. Because that makes it really clear. My ultimate goal on this problem is, on number 1, is to get b equals stuff. And everything besides b is going to be on the right-hand side of the equation. So this is my goal. Goal, b equals stuff. Then I'm asking myself, what is preventing b from being by itself right now? What is on the same side of the equal sign as b? And that's h. What are b and h doing? B and h are multiplying. There's no addition, there's no subtraction, there's no division, so they are multiplying. And how do I undo multiplication? I divide. So I want to divide by the thing that's preventing b from being alone. Over here, b times h divided by h, those h's are going to divide to be 1. So all that's left on one side is b, and on the other side I have a over h. So originally this was the formula for the area of a rectangle. Area is base times height, and I have manipulated it to solve for b. So if I was given the area and the height, I could use those two pieces of information in this equation to find the base. Looking at number 2, and number 2 is probably the hardest one on this page because it has some math that we're going to focus on more second semester, which involves squaring. I want to isolate r. So right now there's two things preventing r from being by itself. There's pi, which you can't really see under the red, and there's a squared sign. So pi is being multiplied by r squared. Let's deal with that first. To undo that multiplication, I'm going to divide both sides by pi. So now I have the area divided by pi equals r squared. And what is this a formula for? This is the formula for area of a circle. So right now we're trying to solve for the radius. If we knew the area, could we figure out what the radius was? This is the part you're not going to be assessed on in this class, because not until second semester at least. We haven't talked about how do I undo squaring. We've talked about how do I undo addition, how do I undo multiplication, division, subtraction, but we haven't talked about undoing squaring. And the way that you undo squaring is to square root both sides. So the final answer here is actually going to be that r is equal to area divided by pi, and we're just going to leave it like that. That's a tricky one. I don't really want you to worry too much about the squared sign portion because, again, that's more of a second semester topic. Number 3 is the formula for the perimeter of a rectangle, twice the length plus twice the width. Our goal is to get w by itself. So the very first thing I want to get rid of, so I'm asking myself, what is in the way of w being alone? Well, there's a 2L in the way, and there's a 2 in front of the w. Just like when we're solving an equation, I want to get rid of the stuff that's not connected to my variable of interest, in this case w, first. So I'm going to subtract 2L on both sides. So I'm going to have that p minus 2L equals 2w. Now w, my goal is to get w equals and then everything else on the other side. Now I need to get rid of the 2. 2 and w are multiplying, so to get rid of that 2, I'm going to divide. So w is equal to p minus 2L over 2. And that's going to be your final answer there. Number 4 is the area of a trapezoid, and that's sort of something that looks like this. And our goal is to solve for h. And here's another one of those circumstances where you see parentheses and your brain is telling you, I should multiply. But if our goal is to get h by itself, multiplying or distributing h in here is going to mean that more things are connected to h. We don't want that. We don't want more things to be connected to h. We want h to be all by itself. So the first thing I'm going to focus on is how do I get rid of 1/2? Well, to get rid of 1/2, I could multiply both sides by the reciprocal. The reciprocal of 1/2, or what I get if I flip the fraction, is 2. If I do that, I'll have 2a on the left, I'll have h, and then I'll have b1 plus b2. Now I want to get rid of b1 and b2. What are h and the quantity b1 plus b2 doing? They're multiplying. So to undo that multiplication, I'm going to divide b1 plus b2. So the solution is going to be that h, or the height, is equal to 2 times a over b1 plus b2. And you can have parentheses around this, and you don't have to. It's up to you. All right, I really want you to pause the video and try and solve 5 and 6 on your own, and then unpause the video and see how you did. Okay, number 5, our goal is to get L by itself. The things that are in the way of L being by itself are W and H. And L, W, and H are all multiplying. So in order to get rid of W and H, or to move them to the other side, I need to divide. So L is equal to V for volume over W times H. I have now solved for L. I'm going to make this a capital L, otherwise it kind of looks like a 1. So we rearranged the volume of a rectangular prism to be solved for L, the length. Last problem, number 6, this is surface area of a cylinder, and our goal is to solve for H. So I'm asking myself, what's in the way of H being by itself? Pi and r squared. And what are pi, r squared, and h doing? All of them are multiplying together. So to undo that multiplication, I'm going to divide. I'm going to divide by pi r squared. So that gives me that h, which is the thing I wanted to be isolated because they told me in bold to solve for h. H is equal to S, the surface area, over pi r squared. So a couple of things to remember. The purpose of solving a literal equation is to have it isolated for a different variable in order to make a process later more simplified. You will always be told which variable you need to solve for in the original problem. Remember that you do not need to use set notation for these answers because these answers aren't a value. They are just a manipulation to create a new equation. And that is how we use and manipulate literal equations. Thanks for listening.